And we're starting with a cubic function, and it's in factored form. So now we need to convert this equation to our general form or our standard form. Ideas on how we're going to get this started. Ideas. Put it in Desmos. We will put it in Desmos, but right now we have to convert it to standard form. Distribute. That's correct. We're going to distribute. And what should we use? What tool? The box. We're going to box. Now, why the box? You're going to see the box is going to get bigger. So before Ellie recommended we distribute that too, would you like to do that first? It's going to be okay. Shh. So let's distribute that 2 first, and let's multiply this out. You can't see? Oh no, it's on there. Let's just relook at this. Do you guys see this beginning? Is this the same equation we just did? Yeah. Okay, so what is new? What are we adding to this? The x plus 1. So what we're going to do is we're going to skip a step. Normally you would start with a 2 by 2 box. Okay, but we already did that up in number 1. So now I'm trying to multiply out 2x squared minus 2x minus 12. That's what we got from number 1, and I'm adding in x plus 1. So my question for you is, what size box do you think I need now to multiply that out? A rectangle, you're right. How big?
3 by 2.
3 by 2. So now our boxes are getting bigger. It's going to be okay. Now our boxes are going to get bigger. Do we see why it's bigger? It's okay. This has 1, 2, 3 terms. This has 1, 2 terms that I'm multiplying together. So do we see how it's a 2 by 3 box?
Yeah.
Okay, let's do it. We're going to do x plus 1 on the left. 2x squared minus 2x minus 12 on the top. X cubed is going to go on the top left.
Negative 2x squared.
Good. Then what? Negative 12x. Hi. 2x squared. Well, it's going to go right here. Negative 2x. In the last box, negative 12. We're multiplying on negative 12 times a 1. I'll give you a second. Make sure you have that written out, because now we're going to write it out. And yesterday we talked about polynomials. What term should go first? The highest degree. So 2x cubed has my highest exponent, so it's going to go first. So 2x cubed. How many x squares do we have? Pause. How many x squares do we have? 0. Why, Michael? Yes, notice that these cancel out, so I do not have an x squared term. How many x's do I have? Negative 14. Okay, notice how I circled those diagonals. Okay, if you like to use highlighters or pens, I would circle those diagonals. We always start with the highest exponent. You're going to notice some things combine, and then what's the last thing? Minus 12. And so here's my standard form. So right now you're going to graph the equation. What do you predict is the y-intercept? Okay, negative 12 is your prediction. Let's graph it on Desmos and see what we get. Hopefully you figured out your x-intercepts. Negative 2, positive 3, negative 1, and now you're sketching it. Talked about in that first graph. Listen. Remember how I talked about in that first graph, our x-axis went by 1s and our y's went by something different. Should we change the y so we can see it? Sure. Click up in the top right. Click this little wrench. Do you see the wrench? It says graph settings. Click it. You should practice this on your computer. Okay. Gavin asked a great question. What's the domain? What's the domain of this graph? All real numbers. What's the range?
I don't know.
It's going like this, right?
Yeah, all the numbers.
Yeah, it's all real numbers. It's going from negative infinity to positive infinity. Will you add this on your graph? The top one's going to infinity. The bottom one's going to negative infinity. And yeah, the range is all real numbers. Can you add that to your graph? I know my graph is a little wonky. What? Graph the correct x-intercepts. And then just swoop it through. Okay, next page. Here we go. Today, factored form. Okay, we talked about the general form or the standard form. So we're going to split our box into two. The two forms. Factored form. The general form or standard form.
Does she teach freshman?
All right, factored form, an example that we did. We had an a value out front. We had 3 factors. That's the example of the factored form. Then we converted it using a box. And we converted it to standard form. And we got 2x cubed minus 14x minus 12. Okay, and we're going to come back to the box. So the important features of factored form. Why is factored form important? You guys tell me, what features of the graph can we see? Yes, we can see the x-intercepts clearly. The x-intercepts, they come from our factors. We can also see our a value. In this example, our a value is 2. Then we can quickly convert. We can quickly convert from our standard form to our factored form using a box. And then again, using a box that's a little bigger. And as our polynomials increase in degree, our boxes will increase too. It's exciting. From the general or standard form, what features of the graph can we tell? The y-intercept. The y-intercept is going to be your c value or that last number. It also tells you the degree of the function. The degree. Remember, degree is the highest exponent. We talked about that yesterday. So right now, for that first one, I want you to use Desmos. Yeah. Gavin, you got a Chromebook, sir? So right now, we're putting this into Desmos. What are your x-intercepts? The things you should notice. What are the x-intercepts? It's going to be at -3. We've got an x-intercept at 0. That also means it's our y-intercept. And then you want to graph these points. Our max, our min that are in between. We're graphing this on our paper. How did your sketch go? Okay, I'm going to put mine on my graph. We're going to do one more problem together, and then we're going to pass out the homework. Well, I want to do number 2 because it's on the homework and test. And the test. Okay, let's do number 2. You ready? Number 2, I would circle it. It's a homework question. It's a test question. Okay, we need to write an equation for a 4th degree function with x-intercepts -4, -2, -1, and 1, and goes to the point 0, -24. If I have the x-intercepts, how could I work backwards to those factors? If my x-intercept's at -4, what would the factor be?
4.
X plus or minus 4?
Minus.
Plus. And what would the next factor be if my x-intercept's at -2?
X plus 2.
Good. And what would the next one be?
X plus 1.
Good. And the last one?
X.
Fantastic. Notice how I put an a value out front. In order to make sure it goes to that a value, I need to use this point now. And I'm going to plug in 0 for x and -24 for y. So let's do that right now. And let's solve for our a value. I'm putting in -24 for y and 0 for x. Let's see if you can simplify that with your group. Give it a try. We should get our a value is 3. What questions do we have about factored form? General form.